Okay, Surendra sir, so shall we start now? Okay, sir,
Yes.
please. Yeah. So, good afternoon, everyone. This is Gopal, and you're watching my YouTube channel, Gopal Mathematica. And today I'm very excited to host the most special event on my YouTube channel. That is this National Mathematics Day special event, which is going to be a very interesting one. And the topic for today's talk is The Beauty of Mathematics with Geogebra by Dr. Surendra Nath Reddy. And he is an assistant professor at SRTM University, Nanded, Maharashtra, and who is an expert speaker of GeoGebra, who gave a number of talks on GeoGebra in various occasions in national and international conferences. And I met him in 2021 in an international conference of GeoGebra, which was a very interesting one. And along with me, a lot of other participants have enjoyed this talk by Professor Surendra and many other eminent speakers along with him. And now I'm very excited and very blessed to have Professor Surendra with us. So I welcome you, sir, to my YouTube channel, and a very happy National Mathematics Day to you and all the participants who are in Zoom meeting and as well as in YouTube. So now I request Professor Surendra to take over the charge of this session and enlighten us with the knowledge related to GeoGebra and other apps. Thank you. Thank you so much, sir.
Thank you, Gopal, for inviting me here. And I see you are doing wonderful work to your YouTube channel. So when you asked, I thought I didn't say no. First of all, happy National Mathematics Day to everyone. Uh, it is a pride moment for all the teachers as well as students who would like to pursue in mathematics. Um, Great, legendary, genius mathematician Ramanujan. We are very unfortunate that he lived for a small duration. Everybody knows that 22nd December is celebrated as a National Mathematics Day, which was announced by former Prime Minister Dr. Manmohan Singh in 2012. From that year, every year, many activities across the country are happening, and people like Gopal and other things. It is really interesting to see that some activities they are doing. Uh, I hope many. It is a combination of students and teachers. So basically, see, mathematics is a subject which you like the most if you understand, or you hate the most in the other case. Okay, so there are other choices for other subjects, but for mathematics, it is like only two ways. Either you just hate. Okay, so how you like the mathematics is by understanding. Okay, so how we can understand mathematics? By knowing each and everything, especially at basic level. So if you see, whoever are afraid of mathematics actually starts from school age. So they start hating from that time onwards, and they never want to touch again. Uh, so now, at least some part, technology is helping to understand mathematics in better way at early age. Okay, starting from early age, obviously you can go up to higher education, and even in research, technology is helping a lot. Okay, so today I'll be discussing on one such technology called GeoGebra. So basically, GeoGebra name itself suggests it brings algebra and geometry together. Okay, so for example, if you want to draw a circle, there are two ways. Either you enter the equation of the circle, or you draw the circle then you get the equation. So GeoGebra gives both ways. Either you draw, then you get the equation, or you enter the equation, you get the geometrical picture. Okay. It is not only about geometry and algebra. It has lot of other features. For example, three-dimensional augmented reality. It is there. Three-dimensional objects you can view. You can make things interactive. Uh, Also, you can use spreadsheets and other things, like you can solve some differential integral equations like that, which is which you may not learn immediately in just one lecture or something. But in today's lecture, I will try to give a basic introduction to GeoGebra, where anyone can start and try to explore if you are interested. Okay. So let me share my screen and show some of the things. Okay. So you can see this screen. If you go to this GeoGebra website, this is the official homepage of the website. You can see here there are n number of applications already available here, and left hand side you have this news feed, resources, people, classroom. GeoGebra has one interesting feature called GeoGebra Classroom, where you can connect with your students and see lively what work they are doing uh, through this GeoGebra Classroom. If somebody is trying to draw something, somebody is trying to calculate something, so whoever joined in this GeoGebra Classroom, of course, when invited by a teacher, then they all can will be in one class. Whatever activities they are doing, that teacher can observe it. Okay, that is one very interesting one. That whether students are really doing or not, we can check. There are different types of GeoGebra has different uh, you can say math apps for different use. And there is something called usually suite is there, classic suite, which have all the apps inbuilt together. Okay. You can see here so many resources are available. As I said, if you have a little bit interest to learn, then you can learn yourself, because everything is available. For example, if you click on what are the resources available here, explore the mass resources. So whatever resources you want to see, you can see from here. You can search it, and you can for example, algebra, geometry, measurement, probability and statistics, anything you feel from uh, grade 1 up to higher education, everything is available. Okay. Even you can see, for example, just want to learn someone about multiplication. If you just, it is a very basic one. Okay. Multiplying two-digit numbers using partial products. So you just go through it, and you will straight away, you can able to see and access that, because GeoGebra is completely free. You can feel free to access. Okay. So here you try to enter what is this value and what is this value. You can see that how it is been explained through multiplication, which we know already how to do it. 40 plus 6. So here you write here 40, you write here 6. Then 14 you split into 10 into 4. So obviously this will be how much, say for example, you can write 400, and this is like 60. And now this is 40, because this is 4 and this is 40. So 160, if I'm not wrong. Okay. And this is 6 and this is 4, say suppose 24, and check whether you are correct or not. Okay. And it says you are correct, because it explains step by step. I mean, what I mean to say is why we are doing like this. This may be difficult, but when you try to split into like this, it becomes easier. For a student who want to learn mathematics, why it is correct, you can always take the help of this type of animated or what I can say, interactive softwares, and obviously it is free, so one can try to explore it. This GeoGebra is available. I can go back and you can search whatever you want. Say, for example, if somebody want to find LCM, okay, LCM of two numbers, then you can see here there are n number of activities somebody might have did it, and they made it available so that whichever somebody want to learn how to find, you can just go through it, anything which you feel like, and you can start learning from that. So it is not like you have to, as a teacher or as a student, you should know everything. Not like, you can learn from already available resources from them. Okay, it will say what is why it is called HCF, LCM. Okay, everything, n number of resources are available. You just need to know the basic things, how to start and what things you have to know. Then whenever you want to learn something little more complicated one, you can take the help of these resources and you can try to understand these resources. If you want, you can use it, that resource as it is, and make it avail, edit whatever you want and save it as your resource. If you see this right corner, there is something called sign in. So every GeoGebra, you can have an account. Once you have an account, advantage is whatever applets you create, they all you can save it online. And whenever you log in with that from whichever computer, you can access those. Okay. So now I have logged in here. You can see some applets I have created here, and usually whenever I give some talk, I give live, and at that time those things I save it as it is. Okay, so that if I want, I can share it, or these resources, if I made it public, anyone can access these resources, this applet, okay, as a resource. Okay, and you also have people. This is one good thing, that if you want to learn something, for example, I am following these two people. This Tim Brzezinski is one of the best person I found while explaining this GeoGebra resources. So basically, if I want to learn something, I usually go and see his videos first or his applets first, and then I will try to learn on my own, because he explains so nicely that with his explanation, it is sufficient. You will understand with one go. That is the beautiness of this guy, and he's really what I can say, he is having excellent knowledge about GeoGebra. So I can suggest, if anyone want to learn more about GeoGebra, you simply go this Tim Brzezinski on his, he has a almost all videos on YouTube also with clear demonstration. Okay, fine. Then with this basic things, you also have apps. For example, here you can download apps. Apps are available for Android also, as well as Apple, for mobile, tab, and this computer you can download, or you can straight away use from browser itself. Okay. For example, if you want to see how it look like in whoever using, you just go to Play Store, and in Play Store, this, if you go here and just type GeoGebra, this screen is not working, but if you just type in GeoGebra, you will get classic GeoGebra. You try to download that one, or if you, even if you go here, and this is the app, you can download it from GeoGebra Classic Suite. So if you want to download on your mobile, then use this GeoGebra calculator suite, and there is a if you just want to use three-dimensional one, then you use this GeoGebra 3D calculator. So this GeoGebra 3D calculator is mainly for three-dimensional objects. But when you download this one, it has all the options. Whichever you want to select, you can select. For example, if you see here, this screenshot, it says which app you want to select. So you can select that, and accordingly you can use it. So which app to download? If you have any doubt, you simply download this GeoGebra suite, calculator suite, which it has all the inbuilt app. Whatever it may be, a two-dimensional, three-dimensional graphing, uh, all those things. Okay, fine. Now let's go back to how we can start basic things from GeoGebra. Okay, so there is a GeoGebra Classic. So you can just type here. This is the GeoGebra Classic. How it look like. So this version is the sixth version. You can download offline also. You can use it, or you can straight away use from browser version itself. So in this GeoGebra Classic version, you can select. At present here it is showing. You go here, and there is a perspectives. So if you select this one, if I click on, say, for example, 3D graphics, then it will change to immediately 3D graphics. If I go here and change this to geometry, then it will come as a geometry. And if I go and see view, there is a view option, and I can select here whichever I want to see. For example, I want to see together algebra and graphics, then algebra and graphics will come. If I want to see graphics too, and I don't want to see graphics, I can. And if more than one you want to see, you can see. So for example, I can select this three-dimensional one. Okay, and algebra, and then I can have a 3D one. Okay, algebra, graphic calculator, and I at present I will start only with this one. Okay, this classic one. We'll go with this, and later we will explain what is a three-dimensional one, how you can see. Okay. Now, whatever we are having here on top of this one, so this is basically a toolbar. What are all the tools available here? Okay, and this left hand side, what you are seeing here, this plus symbol, and here you try to usually enter the command, and you will see this left hand side. This is the algebra view. Okay, suppose if I type simply 0, 0, then immediately here you see that this point is there, and this simultaneously on this graphing calculator also you have a point. Okay, so whatever you do, either you do here or you do here, it reflects in both places. Okay, suppose you want to put a point on a graph. Suppose I select a point, then I click here. So the moment I click the point here, B, you can see that left hand side you have a point. Okay, B is equal to 6, 4. So what are all you can do with this one? You have a point. You can put how many points you want. Wherever you want, you can put. The moment you put points, their algebraic values are shown in this algebra window, left hand side. Okay. Now, then if you go through this here again, you have n number of things to do it. Okay, that midpoint or center. Here you can have a line. You know, the moment you scroll on top of this and left hand side below, you will see that what is the meaning of this segment and how you can form it. It says that select 2 points or positions. So if I click on this, I'll select this point and this point. Then moment immediately this segment is already constructed for this H and P. If you want, what other things are here? A segment with given length, it is possible. A ray is possible. Polyline is possible. Means collecting more than 2 lines. Suppose I'll select all vertices, then where I started, I will come there. So this will be the polygon joining these 4 lines. 1, 2, 3, 4, 5 lines. Okay. So everything you can experiment, and you can also join a vector. For example, if I want to have a vector from here, then up to G, I can have a vector with arrow it displays. Okay. And the difference between joining 2 points and a vector is, in left hand side, you can see that this vector is defined, is shown as in the form of a like a column matrix. Okay. A vector form. This is basically a vector from a point. So wherever you want, you can start and you can do this, and it will go from that point it will go to that. Okay, so that is the one. This is about basically about putting points and having let me erase this and have a simple 1 or 2 points. So here we have seen now different lines are possible. So now you know how to plot a point on this graphing calculator and joining any 2 points with a line segment, or you can have a line also directly. For that line, you need at least 2 points. Okay. This we have seen quickly what is there. Then you also have you can draw perpendicular lines, you can draw parallel lines. So it also explains what is how you can draw a perpendicular line. So to draw a perpendicular line, you should have a point and a line. That means you will draw a line passing through given point which is perpendicular to the given line. So we should give a one line and 1 point. Then we can construct a perpendicular line. So for example, I will take 2 points. Okay. Then now I will join, say for example, I will join the line joining passing through this. I'll select this. I'll select. So now I have a line passing through these points A and B. Okay. Now you see here, I will construct a perpendicular line and a parallel line. For example, if I want to have a perpendicular line, so again what it says, you need one line and a 1 point. So I will select this line. I have selected this line and now I will select my, see you see if I am moving it, the moment wherever I touch, it will create a perpendicular line passing through this C and which is perpendicular to AB line AB. Okay, that is, and if we want to construct a parallel line, so again we need a line and a point so that it will draw a parallel line. So I'll select this this line and I'll this what you have a, this is the line. Now what line we have constructed? This is the line constructed through passing through D, which is parallel to this line AB. Okay. So in this way, you can construct and go through it, everything, angle bisector, tangent you can draw. Okay. So if you want to select a point or line, then circle, conic, or function. So basically you should have either circle, a function. Okay. Then you select a point and it will draw a tangent. So they are all like self-explanatory. You can just go through each and everything and you will find, for example, this is like best fit line. Okay, suppose if you want to see best fit line, let me select some points. Okay, so I'll select some points. Okay, then I want to construct a best fit line. Select several points. So I have selected. So it is trying to draw the lines, different possible lines which are passing through this thing. Okay, then you can see that wherever more points are there, that we can select, right? Okay, here you can see this fit line C to D. Okay, if you change this, for example, I will change from fit line from A to O. Okay, then this is the equation from which it is fitting from A to O, that is the line which passes. Okay, fine. I don't want to explain each and every topic. They are all self-explanatory. Okay, I'll explain few things, and based on that we can construct many things. So far we have seen points, lines, how to construct a perpendicular line, parallel line. Okay, now we will try to see polygons. Okay, how we can have polygons. See, this have a polygon, a regular polygon, a rigid polygon, or a vector type of polygon. Suppose if you want to select a polygon, what it says is select all vertices, then first vertex again. So I say, suppose I start from here, I can go how many I want, but when it will end only you select the first vertex which we have started. So this is one polygon, and you can see that n number of things are generated here in algebra. Okay, this many you have selected. Okay, fine. Now suppose I have another one, a regular polygon. The regular polygon means we know already length of each one is same. So you just need to select 2 points and enter how many number of, so I say suppose I select one and this. Now it will ask how many vertices you want. Suppose I select 5. Okay. Then this is constructed. You can see here, this is a regular 5-gon. So you will have 5 sides for this one. And you can move these things and you will see that if you observe in these 2 images, there are some points which are marked in this green color, blue color, sorry, and some things which are marked in this black color. So this black color one, vertices, this you cannot move it. Okay, they are not dynamic one. But whereas this G and H, because we have selected points from this, whenever you select a point from this, they can be always movable. And based on that, whatever these are depending on G and H. So the moment you change this G and H, those K, I, J values, they also change. Okay. So this also we require. If you want, you can have a rigid polynomial, polygon, and so on. This is another one. Now let me show quickly how we can construct circle. Okay, and after that we will come some standard constructions which we see it in school or elementary level. You suppose you want to construct a circle. Circle can be constructed through center through point, or circle can be constructed with given center and radius. Suppose I want to construct a circle with center through point. So I will select my circle center here. Then you see here, the moment I am scrolling mine, it is showing immediately circle there. The moment I click somewhere, that means this is a circle whose center is A and passing through the point B. Okay. And now left hand side, you can see that this circle equation is already constructed wherever you have simply drawn. It is x plus 6 whole square plus y minus 3 whole square equal to 4. That is the circle of this. Okay. Or you can also construct a circle with given center and radius. Okay. Suppose I select this, somewhere here is my center. Now it will ask radius. Say suppose I give 2. Okay. Then it constructs the way I can, you have a circle with center C and radius whose radius is 2 here. Okay. This is the equation of the circle D, and this is the equation of circle C which passes through 2 points. Okay. And you can construct different ways circle through passing 3 points. So you simply select this and try to give wherever you find. You can see that after the moment you put 2 circles, then it will find out this is the circle passing through 3 points. Okay. Fine. And other things you just see it. Here you can also have a ellipse, hyperbola, parabola. So select point, then DirectX. If you want select 2 foci, then point on hyperbola to get a hyperbola. Conic through 5 points. So if you select 2, 3, 4, and then say 5, this is the conic which is constructed through 5 points. Okay, and you will see here the equation of that conic also. Conic. Okay, fine. And then we also have angles. So let me explain that quickly. Then we will see how we can club all these things. So to measure an angle, let me draw quickly a polygon. I got a this triangle. Okay. Now I can make the angle. To make the angle, you have to rotate in clockwise direction. Suppose I want to make an angle at B. That means I should start angle, it is CBE. So I should start from C, then go to B, after that E. Okay. So if we go clockwise direction, you get inside this interior angles. If you go anti-clockwise direction, you get exterior angle. Okay. Now if I want to make angle at A, then I should go in clockwise direction. That means I should start from B, then I go to A, and then I go to C. So you will see that angle as. Now if I want to measure the angle at C in clockwise direction, so start from A, then go to C, and then go to B. You get this. Okay. And you can move these objects, colors. You can make it if you just right click here, settings, you go to color and say, for example, you can select whichever color you want, and you can increase the opacity whether you want inside. Okay, you can change the uh, different one. You can show whether you want to show the object, whether you want to show label, name and value. So then this area of the triangle also it will show all those. Fine. So what we have just learned is angle between two two sides. Okay, you can also measure angle with given size. So what it says is select whichever leg you want and then select a vertex, then enter the size. Okay, distance or length you can measure, area you can find. So if you simply select this one, I select this, then it says that area of this triangle ABC is 21.9, which we already seen here, right? Yes. So other things also you can see. Now, the other one is reflection about a line, reflection about a point. So that means, say, for example, if I want to reflect something about a point, select object to reflect, then center point. Okay. Or reflection about a line, select object to reflect, then line of reflection. Suppose I select this, I want to reflect this, and I want to reflect on this through this line. You can see that this reflection through this x-axis, as you can see that we are able to reflect this image. Okay, you can reflect in many ways. Reflect about circle, then rotate around any point. So basically it rotates a point around given angle. Okay, suppose if I select this and I want to rotate this one, I have selected this one, it asks for 45 degrees. Then you see that this one, whatever triangle was there earlier, it was rotated 45 degrees. Okay, fine. And now the last and but most important tool which one's supposed to learn is something called sliders, which is very useful if you want to animate something in GeoGebra. So what we have here is this called a slider and text box. Whenever you want to write something, text box, you can insert images, you can create some buttons. Okay, input button also, check boxes, something. These things are possible. So I'll just, if a text box is very simple, you simply write here and select where you want your text. Then you write here, this is demo on GeoGebra first lecture, say suppose something. Then you click on this and here you have wherever you want, you can put it. Okay, that is simple basic text, so you don't need to explain much. What is interesting is this slider. So basically slider, it is like you can, it is just like a variable. This variable, you can give values from some range to other one with increment, and that can be used to construct in other places. Just like a point. So instead of using say 1 comma 0, the moment you say 1 comma 0, it is fixed. Whereas if I say suppose a comma 0, then and a is a slider, then the value moment a is changing, this point will also change. Okay, so it is like dynamic values. Sliders we can create. So where I want to create, say suppose I want to create here, I will my slider name is a. If I want, I can change this name also. There is no problem. And say suppose it starts from 0 up to goes to 5, and I will say suppose 0.1 with increment. You can give 1, 2, 5 also. There is no problem. Okay. Then I click, suppose I will give 0.5, I'll click OK. And sliders can be three type. One is a number, okay. Another one is an angle, okay. Another integer, okay. It is integer, so only -4, -3, -2 like that you will get. And you have a slider information here, and animation, how much speed you want to animate, that you can check and click on OK. Now you see that this is a slider is created. Slider is created. There is always a play button. So if you click on this, it will go this whatever increment we have given, 0.5, 0.5 increment we have given. So it can, you can go observe like, okay, fine. Let me create one more slider and we'll see where we will use those sliders. Okay, I'll put, and this time B again 0 to 5, 0.5. Okay, click OK. This time also it is there. Okay. Now we have created sliders. We'll try to use this to get something animation. Okay. So first, let me use a point. For example, I'll put a point here, okay, which is a comma 0. Where is that point? This is here. Okay. Now, if you see this, the moment I play this one, my a is changing because my point is defined using this slider. So my point is changing here. Okay. You can observe here this a is moving. Okay. Fine. I will also take my, say, suppose b, I will put another point which is the 0 comma b. Okay. This is here. Now, if I keep moving here, you will get it, right? I have 2 points now. Let me join this line, say, for example, I want to get line segment. I'll join this A and B. Okay. I'll join this line segment A and B. Now, the moment I play this, you can see that it is just like assume you are having a clock and okay, you can have it is going, instead of going from 0 up to 5, you can have different places. Then you will see that it is just like going like a clock, right? Fine. And if I start playing this B also, then it will move A and B together. So a small animation we have created that your line is moving somewhere here and there. Okay, fine. Now, suppose I want to let me construct a circle. Then I want to make it circle small or bigger one. So obviously I will put one point here. Okay, let me put a point. Now I want to construct a circle with this point as my center, but radius, instead of giving my fixed radius, I will use this slider. Okay. So I'll click on this. Now it will ask radius. So I'll give my point as A instead of giving a fixed radius. Now you see that the moment I decrease my A, this slider circle is also getting smaller or bigger. So this circle, you will see that it is getting smaller or bigger. If I make it my what slider with increment 0.1, you will see this is even in better way. Okay. For example, here instead of 0.5, if I give 0.1, okay, then if I play this, you will see that a lot of softness is there now. Instead of jumping too quickly, you can see this is there. Okay. Fine. So this is one beautiful usefulness of having sliders. Now, can you think of creating a circle? So if you see this circle, it is center is fixed, but circle becoming smaller and bigger. Okay, that means this circle becoming smaller and bigger, but it is the center of the circle is fixed. If I want to make it my circle is also moving, so how can I do that? Yes, any idea that how I can make it circle move here and there? That means I want to move my point. So instead of this C, if I make it my circles, this is instead of C, okay. If I write this as my B, okay, then if I click on this, now you see that this circle center is B and radius will be depending on A. So let me play this and play this one. Now, if I stop this and if I try to move this, now you see that this circle is moving here and there. Okay. Circle size is fixed, but circle is moving here and there. Okay. So if you play both, then circle will become smaller and bigger at the same time. It keeps moving. So if I want to now I can remove these slides also. Yes. So you can see such type of things as per your imagination. Sliders can be used as per your imagination. You can use as a number, you can use as an angle. So if you use angle, it will be moving as per the angle you have given. Okay. You can have a gems like integers you can use. These are very much useful while creating small animations. You can move from one place to the other, or you can make it bigger or smaller, and whatever it is, like how you use your sliders, it matters. You can rotate the things. For example, you just imagine how you can create a clock in GeoGebra. That is your one example. Like in clock, it will go. There is a center, right? You will have two, one small line and one bigger line. A small line should move in different speed, and a bigger line should move in different speed, and they you should rotate them using angle. To try to use this slider for the that one, or you have to create the points and that you have to test. So I request whoever watching here, can you create a clock using GeoGebra with the help of these sliders? You can do it. It is not at all difficult one. First, you should have a clear picture. Okay, if I want to create a clock, what things I require? Okay, you, for example, you require you want to have a clock. So for that, you make it like a circle. Then you have a center point. Then you try to make two sliders. Okay, one from that B to, you put some other point with smaller size, you join that one. Then from B to another bigger line, you join that. So you have two lines. You have to move these two lines, okay, as per this one. So try to move the bigger one. The bigger one should move in some speed. The smaller one should move in some speed. Forget about whether the time is as per accurate or not. But at least try to move, make it some animation which just look like a clock. So for that, you should have 12 points. So in that circle, you try to make it 12 points, made it 1, 2, 3 up to 12, and make these two lines and prepare like a small clock with animation. You will see that you like GeoGebra in that. Fine. Now, let me see some constructions, basic constructions, how we can do it, whatever we have learned so far. Okay. So let me clear this. Fine. Suppose I want to say, for example, here if you take this polygon and regular polygon, and if you give three sides, then equilateral triangle will be constructed. But I want to construct, say, for example, an equilateral triangle, or a square, or a rectangle, or a parallelogram. How we can construct? So see, the construction in GeoGebra, not only just drawing something here, it also gives a lot of information like how we construct. So you will learn and you will verify it, whether whatever your idea, whether they are correct or not. Okay. So for just a quick example, let's see how we can construct an equilateral triangle and say, for example, square, so that you will see so many things, whatever we have discussed, we will use it. So for that, what you do is, suppose you take 2 points. Okay. So let me take some 2 points here. And, okay. Anywhere you can take. There's no problem. Now I will construct a circle with center and passing through this. So I will take this center and I'll this. Okay. And I'll repeat the same thing. I'll select this as my center and this time this. Okay. Now you know idea, like you want to have a point of intersection of these two. So you have an option here, intersect. So you select this object as well as this object. Now you see there are 2 points, C and D. These are the points of intersection. Okay. Now you simply, for example, I don't want to show this one. So you can simply hide that. And now you join this line segment to C to A, then A to B, and B to C, for example. Now you can check that this one is whatever we just constructed is an equilateral triangle. Why? For equilateral triangle, all sides should have a equal length. So you can check that here. F, which is segment of CA 3, 3, 3. So obviously all these sides are 3, 3. Okay. If you want, you can change this, and you can go to settings, and in this label you can give it as a name, value, and label. So then you will see that this value is 3, and all other you can change like fine. Okay. Now it also require that angle should be 60 degrees. Okay, internal angles. So you just go here. I want to have an angle at A, so start with B, then A and C. So you see that it has 60 degrees. Now start with A, go to C, B. It is again 60. C, B, and A. So it is again 60. So all three angles have equal 60 degrees, and they have also equal length. So you can see that what we have constructed is an equilateral triangle. So you can simply, if you want to say that this, you write it as text here and type, this is an equilateral triangle. So wherever you want, you can put it. How much big you want, you can make. Okay. Now, so for this equilateral triangle, we should know the concept, like how we can construct an equilateral triangle, and that we have used the software to verify, okay, whether this whatever our idea is correct or not. Okay. Suppose I want to like keep it that point there. I want to construct a square. Now for this, how you can construct a square? So all sides should be same and angle should be 90 degrees. Okay. Right. So for that, again, say for example, I will take 2 points. Let me take this 2. Right. Now I'll join these points also. I have joined. Now to construct a square, what we require, we whatever the other line, obviously it should be parallel to this one, right? Or the other one, it should be perpendicular, because 90 degrees should be there, right? So how we can construct a perpendicular line? Go here, perpendicular line. So I'll select this line and I will select my point. Now I got a perpendicular line. Similarly, I'll select this line and I'll go this. So I got a perpendicular line, right? Now I can take any 2 points here, but that need not, we don't know whether it is a square or not. For that, we have to make sure that this whatever length of this FG, wherever we are going to take this point, that length again, it should be same. So how we can select that? Again, it is a simple, which we know already, is simply select circle, this, and circle with point. So I'll select, let me make it this first small, so that, see, that is one advantage here. You can move these things because you have put a point using this one pointer. Okay. Now I want to make it what circle with 2 point. So I'll make it this, and again I will make one circle with this as a center and this as a radius. And now you can see that if you have this point of intersection, that why it is, can you see why it is the same length? Because whatever this FG is there, that we have taken here as a radius. So obviously this will become same as FG. So I go here and I will try to see that point of intersection. I will select this line and this one. So this is a point of intersection. I'll select this and I'll select. Okay. So now I don't want these circles. So I'll remove this. I will hide these circles. I'll try to join this line I to this. Okay. Actually, we can take the line segment instead of line. So I'll take line segment. Then I'll join I, J. Okay. Then this all lines we can remove now. You can join this I to line segment. So take this I and F, take this F, G, G to K. Okay. Now I can hide these lines and all and so on. So I don't want this. So this perpendicular line. Yes. Now what we have constructed, it is a damn sure it is going to be a square. You can again I leave it that as exercise. You can try the measure the angles and you can check the values. So you can easily check the values. It is already there here. Segment QNMI. They are already the segments. Each one is of length 2.6. So that measurement is already there. You have to just verify angle. I'll show just one angle. You take this one, suppose F, then I, then K. You can see that it is 90 degrees. So in all will be 90 degrees. That is there. So similarly, you can construct different types of objects, geometrical objects, which we are not sure at the time whether whatever we have constructed is correct or not. And we can verify here clearly. Okay. These are some of the just constructions, and I have given just one or two constructions. You can construct whatever is possible. You can experiment in n number of ways. Okay, it is not like only this is the way you can construct. You can construct in many ways. Okay, don't construct by taking this as a fixed length, then again here fixed length, here fixed length, fixed length. Not like that. Okay, a proper construction where a geometrical construction can be defined, right? Okay. Then there is one which I would like to show. This is about two-dimensional. You can plot a diagram and graph, and you can see those things. Suppose, let me clear this. The moment you draw here, say for example, sine x. Now you see, the moment I type here, it is already drawn the picture sine x. You can define the range, and only if that range you can give it, it will take only in that range. Okay. And if you want, you can find the roots. Say for example, here I'll write here root. So if you say root of polynomial, so you can select root and polynomial. Then if I write here f of x, then these are all the roots. You can see here, so many roots are there. A, B, C, D, E, F, G. These are all the roots of the polynomial. Okay. And whenever you have some function which you want to visualize that how the graph of that function look like. So for example, I'll simply write here x square. Then this is the function x square. And whether they have any point of intersection, they have a point of intersection. If I select this and if I select this, then there are 2 points, this H, and here also it is intersect. Okay. So you can take the help of this graphic calculator also. You can find, that means if you want to say, for example, draw a tangent, you can draw a tangent. You should have a point, and suppose this very, you can have a tangent and all the things you can do it here. You can find the slope. You can whatever we are able to do it, you can do from that. Now, what I will show in last 5 minutes is it also has a GeoGebra is very much useful to visualize three-dimensional objects. Okay, so let me show that three-dimensional objects, and then I'll go here and in my perspective, I'll change this to 3D graph. Okay, now whatever you have here, it is a three-dimensional one. So you have X, Y, Z. Okay, suppose I put something here, that this toolbar, if you observe, this toolbar is changed as per this because it is a three-dimensional one. These toolbars, if you see here, they have different one than the previous one. If I select, for example, center, a sphere, and a point, then I'm getting a sphere. Okay, now you can see it is a three-dimensional picture. You can rotate it. Yeah. So this is like a beautiful one, a simple three-dimensional picture. You can have n number of things. You can have a pyramid, prism, a cone, cylinder, a cube. Okay. So for example, let me draw a cube so that I'll explain something. For this, you just need to take one point and another point. You got a cube here, right? This is a cube. All sides are equal, which is of same length, right? Now, this advantage of this three-dimensional objects is, if you want to know how to construct, then let me put it properly. Okay. Let me put this and this one. So I got a cube. Okay. Now, if you there are some options which are available in three-dimensional, something called, for example, there is a net and surface revolution. All these things are surface revolution means from a two-dimensional picture, a curve, you can create a three-dimensional one. Suppose if I click on this net and select this cube, a net is created. So you can see here with the help of a slider, this net is created. If you play that one, you will see this net. System getting hanged, rotating. So this is one way you can try to understand how one can, suppose you can explain your students how we can, for an elementary school student, how you can form a cube. So if you see this one, like how many sides are required and which side we have to fold it so that you get a cube. So if we can give this as a small assignment, students can definitely learn how many faces are there in a cube, how many edges are required to form such a cube, right? Yeah. And you can, for example, you can go through this intersection of two surfaces and you will have n number of you can create. These are the different three-dimensional objects. You can have a cone, you can have a cylinder, tetrahedron. Okay, for that you need to have at least 4 points you can select. And surface of revolution. So for example, let me show you surface of revolution just for 1 second. Yeah. So suppose this has, I'm connected because it's taking a lot of time. Okay. So let me type, say, suppose a line. I'll try to draw a line from here to line segment. Let me draw a line segment from this to this. Okay. So I have a line segment from A to B, right? This is my, now if I want to make a surface revolution, I go here, where is here? There is a surface revolution. Now, if I try to select this, you see, the moment I try to select here, I got a surface revolution. Obviously, it just looked like a cone, right? Here, my system is getting hanged. So you can see this. This is a surface revolution. You just simply drag this. Is getting. You have to simply drag this one so that that line is, it is just like revolving around that. So that's why it is called surface revolution. So what basically you see is, because it's joined origin and this one, so you get a cone shaped surface revolution, and this can be done manually also. For example, you have this. I'll just remove this and I will write here surface. So you have here surface. I will have a function, right, and an angle, or I will have a curve, angle, and line. So these are the different things you can select how much it has to surface. So for that you take a theta, say it is an angle from 0 to 360 degrees, then try to say, let me, theta is equal to, this is 0 degrees. So from 0 to 30 degrees, 360 degrees I have created. Now suppose we want to have a surface revolution. So just type here surface, then I will select curve, angle, and line. Okay, so here curve, my curve is F, then I'll select my angle as alpha. This alpha I need to copy. Right. This is my alpha, and then I will type it as my x axis. So here there is something wrong. Yeah, so now we got here a surface revolution, which if you moving this one, you will get a surface revolution. Okay. These are some of the things we can do it from GeoGebra, and whatever we done here, that if you want, we can save it here by going in this. There is an option called save online or save to your computer. Suppose if you want to save it online, you need to have a login for that. You can create freely. Even with Gmail, you can log in. Here, I can say if at all I want to save it, then I can say, for example, Surface Revolution. Okay. I don't want to say right now. I can cancel it. Then, if you want to access, if you have saved it earlier, then you can access and you can keep editing whenever you want. You can edit that one. Okay. So maybe it is, I think, 1 hour. Only continuously one side. Any doubts?
No, sir, keep going. We all are enjoying.
Yeah. But if they have any doubts, then we can, otherwise we can stop. That is what I'm saying, because they need to have some hands-on.
Yeah, I request participants if they have anything to say or would like to continue the same.
Because I may not able to show that virtual reality because my uh, mobile is not able to connect to this one. If my mobile is
Okay,
connected to this laptop, I might have shown the virtual reality, but
right.
my mobile is not. My mobile screen is not connected, so I cannot show that virtual reality here.
Yeah, last time, like how you have shown the image of mug, that is what you're saying.
That
Something
I
like
cannot
that?
show it here because my mobile
Okay,
somehow it is not connecting to my laptop.
okay, okay. No problem. So, is there anything the participants want to ask?
Only thing I tell is if you get some basic idea, go and explore yourself, and you definitely like the GeoGebra.
Okay. So, there are some students also in this, school students are also there in Zoom meeting. So, maybe they want to present some poster they have prepared for National Mathematics Day. So, I just
Okay,
want to allow them for 1 or 2 minutes to share their
sure.
work, and then we can ask any questions if they have. Yeah. So, I'll just allow them. Yeah. Now you can start your video and audio. Whoever want to present their posters that they have prepared.
Good afternoon. Good afternoon, sir.
Yes. Good afternoon.
Sir, so we are going to present our chart now.
Yeah, you can do that.
Can we share our screen because the first poster is on Canva. We have created on Canva app.
Yeah. Okay.
Good.
Yeah. Now you can do screen sharing also.
Okay, sir. From where we have to see?
See,
Where? My
see
screen.
in the center it is written screen share, share screen.
Yes, sir. Yes, sir.
Yes, please do it fast.
Yes. Sir. Is it visible, sir?
Yeah,
Yes.
Where it is? So this is our introductory poster that we created using Canva app, and the other three poster that we are going to present are handmade.
good. Yeah, this is good.
I hope this is visible.
Yes, yes, it's visible. Yeah, go ahead. Go ahead with the next chart that you have prepared.
From where we
Now you can,
yes. So
now you
this
can,
is our poster number 2. I hope this is visible.
yeah, you can stop your screen sharing, then you can show it
Stop
because
sharing.
then it will be visible. Yeah,
From there I can't understand, sir. Stop sharing.
yeah,
Okay, sir. Now it is visible. This is poster number 2. In poster number 2, we focused on the characteristics of a good mathematician, and we have also highlighted some of the famous mathematicians' quotes.
good.
Is it visible, sir?
Yes, yes, it is visible.
Can we move
Yes.
forward?
Yeah, you can read out some if you want, or else you can go to your
And
next chart.
this is poster number 3, which I have created. Poster number 3 focused on one of the greatest mathematicians of all times, whose birthday we celebrate today as National Mathematics Day, Srinivasa Ramanujan. We have mentioned some of his significant theorems and functions, along with his famous quote, and an equation for me has no meaning unless it expresses a thought of God.
Wonderful.
Is it visible, sir?
Yes, yes,
Yes. 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 Yes.
And this is our poster number 3, which poster number 4, sorry, poster number 4. In this poster, we tried paying tribute to the greatest mathematicians of all time, whose contribution in the field of mathematics remains unparalleled. Is it
yeah,
visible, sir?
yes, yes.
Yes. Yes.
And
That's
once again,
Wonderful.
sir, I'm wishing you a happy National Mathematics Day, sir.
Thank you. Thank you so much. And you have done a very good job. We can see that a lot of hard work you have done with
Thank
this
you, sir.
posters.
Thank you, sir.
And I wish you all the best for your studies. Go ahead
Yes, sir.
with good learning in mathematics and stay
Thank you.
connected. Yeah, thank you. So now I request other participants if they have anything to say about the GeoGebra talk that professor has done for today. So is there any doubts or anything that you want to share in regards to the talk? Okay, I think uh, the, there's nothing from the participants end. So there is one wish from YouTube. They're wishing happy National Mathematics Day from Saket Wagmare. So is wishing happy National Mathematics Day to all
Thank
the
you. Thank you.
professors and all the participants. So now I want to present a vote of thanks for this wonderful evening that Professor Surendra has done for all of us to mark this day as a very special day. So it's a great privilege for me to present the vote of thanks to our speaker for today's wonderful event. It is a matter of pride for me that I got chance to have him in my channel, Professor Surendra. And I'm also grateful to all the participants in Zoom and in YouTube for their participation. Hope you learned something special on this day of National Mathematics Day. So, thank you so much, Professor Surendra, for being with us and gave us an insight of GeoGebra and its applications. So, thank you so much for being with us.
Thank you all. Thank you, Gopal. And
Yeah,
my best
thank you so
wishes.
much, sir. Thank you so much. So, is there
Take care.
anything else from participants' end for the last time I'm asking? Is there anything much to say? So, there is one message from Sai Kiran Janpala. He's saying, thank you, Surendra Reddy, sir, and Gopal, sir, for this amazing session. So, once again, I wish you all a happy National Mathematics Day and stay tuned with the channel for upcoming talks like Surendra sir and many other uh, eminent people are going to come in this channel. So once again, I thanks to Professor Surendra that
Thank
you
you.
have
Bye.
taken
Yes.
so much of trouble for me and my viewers for giving this talk. Thank you so much. Thank you.
Okay.
Thank you, sir. Again, Sahars is saying thank you, Surendra sir, for this amazing session. So, thank you, sir. Thank you.
Okay.
Thank you. Bye, sir. So here we are ending this wonderful talk uh, on this National Mathematics Day by Professor Surendra Reddy from SRTM University, Nanded, Maharashtra. He's a very expert speaker, not only in GeoGebra as well as in mathematical sciences. He's the assistant professor at that university, and he has been a support for a lot of social and noble work that he's doing. If you can get track of his social media, you can see apart from teaching, he is doing wonderful job in his the social work. So I wish he continues this with support of a lot of people who are supporting him to do this noble work. So once again, thank you so much, all the participants, those who are here. Thank you, Smita Nigam, madam, Dr. Smita Nigam, for appreciating for this wonderful session by Dr. Surendra. And hope you enjoyed it. And once again, we'll meet again very soon with a wonderful talk. So here I take leave, and I wish